Hello everyone, my name is A.K. Mamanatullah, and in today's lab we will look at the bisection method. Mainly, the bisection method is based on the theorem that if we have two x points in a graph and we have a continuous function f of x between those 2 points, and for the 2 points, let's suppose one point is xl and another point is xu. For the 2 points, the multiplication of xl and the multiplication of xu gives us a negative result. So that means that they are on the opposite sides of the y-axis. And for this continuous range between these 2 points, xl and xu, for the function f of x, we get at least one point where f of x equals to 0. And that is the root, and we have to find that point. Now the process of bisection method is, from that range of xl and xu, we find the average. So the average of xl plus xu divided by 2 equal to the new x mid. And for x mid, we see from the graph x mid will be here. And for x mid, we will apply the function on x mid. And if we get a low result or a negative result, then we will change xl equal to xm. Whereas if we get a positive result, then the positive part, and if we get a positive result, then the x which returns a positive result will be changed. So xu will become xm. And we do this process again and again until the xm is as close to the root as possible. And that is how we find the root using the bisection method. Look at the code. So if we have two lists and we pass in those two lists into a dictionary, then we can create a data frame from that dictionary. So here's the data frame displayed with the two lists we created. Now, from our previous lab, we have seen how we can use np.linspace to generate the x values. And if we pass in that list to a function, then we will get the corresponding answers. So to generate a polynomial from the coefficients, we will use NumPy's polynomial class. And this is the constant. This is x to the power 1, x squared, the coefficient of x cubed, and so on. And also, we will generate a number of data points, x, ranging from minus 2.5 to 1.6. We will have 100 points in this range. And applying the polynomial to these x values, we can generate a y list. Now, by inputting the x lists to our function, our polynomial function, we get the y values, and we can plot these values. And we want to indicate the roots. So with the NumPy's polynomial function, we have a method that gets us the roots, and we know the roots will have 0 value. So, and as this has x to the power 5, so with 5, So the number of powers we have, we expect that amount of zeros. So this is done manually, but what we could have also done was, this, that we apply the polynomial function on the x values that gives us 0. So this will give us 5 zeros as well. So now let us look at an example. So presume we are given this equation. Now we have to apply bisection method to find one of its roots. So we have to rewrite the function as this, and we have to solve this equation. Now in the bisection method, we need to first randomly select 2 points for which the multiplication of the functions of the 2 points is negative or less than 0, meaning they are in the opposite sides of the y-axis, right? So if this is xl and this is xu, so f of xl will be a negative number and f of xu can be a positive number and vice versa. Then we can start the bisection methods. So our initial guess is xl equal 1 and xu equal 4. So the functions, after we put the value of xl in the function, we get a negative value. For xu, we get a positive value, and the multiplication is negative. So this satisfies our formula for bisection. So we find the middle value. Taking the average of these two results in 2.5. So xm equal 2.5. We put xm into our function and we get a negative value. So if we think with common sense, so we have to replace xm with xl, because even if we take, suppose this is xm, so we get a negative value for xm. That means we can shorten the range. The range could be shortened. And iteratively, the range will shorten to a point where it's almost close to the root. So for the first step, we have to shorten the range by updating Excel. But to do that mathematically, we can use the formula that we can multiply f of xl with f of xm, and we get 3 options. So the first option is that considering f of xl is a negative value, we also get a negative value of f of xm. So and we can just update the value of xl, because the condition will be still satisfied that f of xu is in the positive side of y and f of xl is in the negative side of y. But if the value is smaller than 0, that will mean that f of xm gives a positive result and then it's multiplied with f of xl. So overall, negative into positive will result in a negative value. So then we have to update xu. So then we change xu to xm. And in the off chance, we luckily find f of xm where f in the off chance we find the value of xm where f of xm is 0, then we can just end the algorithm. So these 3 are the possible choices. As f of xm is negative, so in the first case, the condition that will be applied is we have to change xl. So the xl value was 1, the xu value was 4. Using the formula, we change the value of XL to 2.5. And this is our list of values. So for XM was 2.5. Now, what we can do is we can generate a new XM. So the new XM will be the average of these two. So average of these two. So if we calculate the average, this becomes 3.25. And now we have the scope to generate an error. So error. So the formula of the error is given in the equation above, but here I have done so as well. So now we have two XM to compare with. One is the old XM, one is the new XM. So the formula of finding the error is given in the equations. And here we compare the two XMs and generate the error. And if the error is significantly smaller than our, so we set a threshold. So here we set the threshold to be 10 to the power minus 6. And if the error is significantly small, meaning if the error is smaller than this value, this threshold, then we stop our equation and the last XM is our answer. But if it's not small enough, then we again follow the loop. Meaning now for 3.25, we need to find XM. So for 3.25, XM becomes 14.328. F of XM becomes 14.328 if we apply this to this equation over here. And then it is easy to see that this is a positive value, and that is why XU will be updated. So the new XU will be 3.25, and the old XL will stay the same, as the B option will be implemented here. And then we will find the average of these two. Suppose it's anything around 2.8 something. And this XM will be compared with the old XM to generate the new error. And we can see slowly the distance between XL and XU is shrinking. And it will shrink to a point where the root converges. So